So now, let's see what happens if we put a switch in this. That's kind of interesting. So, I have my pick with its voltmeter. Sorry, I should make that a little clearer. And that's supposed to be ground. And I now have VCC. I have my 10 kilo ohm resistor. Now I've got to use the same trick. Let's pull up resistor. And I am going to sense the state of a switch. So when switch is open, it obviously has, so we're working with input here. This is N1. It's still at VCC, that's fine. But when that switch is closed, what happens? Well, let's do some math here. Well, if we look at this, we basically now have a voltage divider without the bottom resistor. Now granted, this has some really small resistance. But if I look at this from, if I look at this as a parallel circuit, I know that basically the R total here is basically going to be 0. So all the voltage drop goes across this resistor. Since this is 0, this that is being sensed is basically 0 as well. So now by closing the switch, I have gone from sensing a 1 here, so N1 equals 1. Now I have N1 equals 0. Well, that's great. I now have actually gone from the concept of a pull-up resistor to actually being able to do some sensing. And that's the whole point of this anyways. But here's the problem. Remember when I said we have the potential of having an output hooked up here. What happens now if our programmer actually puts this pin to output again? Well, if it puts it to 0, we're fine. Because 0 and 0, there's no going to be current flowing. This is a big enough resistor that, you know, it's going to be some drainage, but it's not going to be a big deal. But if I put the pick to VCC, if I send it to high, and I put it out to be 1, I have VCC going to ground. Oh no, I just blew up my microcontroller again. Well, how can I fix this? Well, one thing I can do is I've calculated what the minimum resistance is to be safe. So, if I want to be paranoid here, and I do, I can put another resistor here that's 250 ohms, and that will keep the system from actually shorting out. But do I still get a decent value here that guarantees a 1 for, excuse me, a 0 for N1? Let's do some quick calculations. Now, looking back at this formula, where we have the multimeter in parallel with the bottom resistor, we get, so again, RT is going to be this. Here, 250 ohms is acting as our resistor 2. Well, I'm getting a very small number plus a very, very small number. Well, if I look at this, this is still going to be approximately 250 ohms. Not exactly, but close enough. So now I know from my voltage divider that the voltage we're going to get there is VCC times RT over R1 plus RT, which equals, in this case, 5 volts. Again, I'm just assuming 5 volts for a pick. Times 250 over 10,000 ohms plus 250 ohms, which is basically 5 volts times something relatively, excuse me. No, this is right. This is what I want to do. So let's see how that's kind of hard to do this one on the fly. 1 over 40 approximately. So it's going to be 5 over 40, which is about approximately 1/8 of a volt. Well, 1/8 of a volt is close enough to 0. But since this thing only can measure 0, 1, it's going to measure 0. So adding this resistor was fine. Because it was small enough, it was very small compared to this, I'm protecting my circuit from the user flipping this to output, while still making sure I get just the 1 and 0 as I want.